Okay. Actually, this is your reference book. Okay, this is the given reference book for our module, digital signal processing, John G. Perkins. Okay, Perkins book. Okay, but I so I will give this book also to you. If you need, you can read it. Okay, but here you can see some description. Okay, so it is somewhat hard to read. Okay, so I rather like to use this this Shom's outline books. Okay, so yeah, this Shom outlines book. Okay, so we will use this one as our reference book. Okay, because I think this book content is enough to cover our syllabus. Okay, so I would like to use this book. Okay, so I think you are already familiar with this book, no? Because in signal and system also we use this book as our reference book. Okay, so I hope you are familiar with this book already. Okay, so I would rather like to use this book because the content is here enough to cover our syllabus, as well as the informations are very little here and they are straightforward. Only the theory, all necessary things are available here. It is just like a short note. Okay, so we will use these books, this Shom outlines book as our reference. Okay, so mainly we are focusing on discrete time signal in our course. Okay, in digital signal processing, we are mainly focusing on discrete time signal. In signal and system, we are mainly focusing on, we have focused on continuous time signal. I already told you that in last time. Okay. And here we are mainly dealing with the discrete time signal. So you can see that the discrete time part is available for every chapter. Okay, so I think this content will be enough. Okay, for us. Okay, so we will use this one. Okay, so I think maybe you can remember that last time I told you that the same thing. Okay, in signal and system we are mainly focused on continuous time signal. Continuous time signal. Okay, but in DSP, digital signal processing, okay, DSP, we mainly use discrete time signal. Okay, discrete time signal. So in last lecture we have discussed some advantage over uh, advantage of discrete time signal, discrete time processing over continuous time processing or analog processing. Okay, so I think you can remember that one also. Okay, uh, uh, and also last time we have discussed how continuous time signal is converted to a discrete time signal. Okay, for that one we are using what is called sampling. Okay, to a sampler we can convert continuous time signal into a discrete time signal. I think previous week we have discussed these things. Okay, I think you have that idea already. Okay. Okay. Anyway, we are we are we will talk about sampling uh, thoroughly in future. Okay, up to this level, please take the idea. Okay, continuous time signal can be converted to the discrete time signal to the sampling process, to a sampler. Okay, sampler is just like a switch. Okay, so I think you have this idea already. Anyway, we will discuss this later. Okay, But at this time, you should have the idea how continuous time signal is converted to a discrete time signal. Okay. So that is enough at this point. Okay. Okay. So now we will see, okay, why we like to have discrete time signal. Okay. Let's see why we like to have discrete time signal, rather than continuous time signal. Okay. Okay. You already know that nowadays we are using digital electronics. Okay. Mainly we are using digital electronics. Okay. Electronics. Okay. So I will take example. Okay. Let's say that people, okay, a person is talking to a microphone. Okay. So we have a person like this, and he is talking to a microphone. Okay. Then this microphone, okay, so we have take this example in many times. Okay. I think you can remember. Okay. Okay. So let's say that the person is talking to the microphone. Okay. Then what happened? This microphone will convert his voice into a electrical signal. No? So that signal is a complicated signal like this. Okay. We don't know this kind of signal we have. Okay. So you know that this is a continuous time signal. This is a continuous time signal. Okay. Because there are the time axis is continuous value. The time axis have the continuous values. There are uncountable values in the time axis. So it is a continuous time signal. Okay. I think you have understand why we are telling that the time axis has infinite value. No? This time axis has infinite value, infinite time value. Okay. Anyone have a problem with this statement? Infinite time value. This time axis has the infinite time values. That is why we called it continuous time. Okay. Are there anyone who couldn't understand that statement? This time, this is continuous time. Okay. That means times values we have infinite or uncountable. Okay, uncountable number of time values. Can you understand this statement? Are there any problem? Okay, I think everyone can understand this statement. No? Okay, because this time has an infinite number of values. Okay, time has an infinite number of value. We called it continuous time signal. Okay, we called it continuous time signal. Okay, so once a person is calling to the microphone, it is generally a continuous time signal. Okay, and if you consider, so we are considering time values. No, there are infinite number of time values. Okay, so what about amplitude level of this signal? What about amplitudes level of this signal? Can anyone tell how many amplitudes levels are here? How many amplitudes levels are here? Please give me an answer. If you consider this signal, this signal, okay. So you have, so it is a electrical signal, okay, normally a voltage signal, okay. So voltage is changing with the time, okay. So that signal may be like this, we don't know, okay. This kind of arbitrary signal, okay. So you already know that if you consider the time, okay, time values, okay, we have infinite number of times value here, okay, infinite number of times value, okay. And if you consider the amplitude, amplitude means the voltage level, okay. Amplitude levels means voltage level, okay. This is voltage level, okay. Amplitude means this voltage axis level, okay. Uh, the voltage value actually, right? Amplitude again voltage value again. Yep. So how many amplitudes values are here? Amplitudes value key මෙතන. Okay, is it countable or uncountable? Countable or uncountable? Give me the answer for this. This amplitudes levels is countable or uncountable? අපිට ගණන් කරන්න පුළුවන්ද ගණන් කරන්න බැයිද? මෙතන තියෙන amplitudes level ගන්න. Can we count the amplitudes level, number of amplitude levels, or can't we count the amplitudes level? Please, someone give me answer. Please give me answer. I got one answer. What about others? Is it countable or uncountable? Okay, tell me what you feel. Is it countable or uncountable? It is okay if you get the wrong answer. That is okay, no issue. Yeah, thank you. Okay, I think I got both answer. Okay, countable. Someone say it is countable, and someone say it is uncountable. That is okay. 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 So I take this signal again. Okay. So we have this kind of signal. No? This kind of signal. Okay. Let's take one part. Okay. Very little section of this signal. Okay. I get this signal from this time to this time. Okay, from this time to this time. Okay, let's say that I take the time value from T1 to T2. Okay, the voltage level corresponding to T1, let's say that it is A1. Okay, and voltage levels corresponding to T2, let's say that A2. Okay, so you have A1 and A2 voltage levels. Okay, so here you have two voltage level, no, A1 and A2. Two voltage level like takes. Okay, okay. So how many voltage are between these two levels? How many voltage levels are between these two levels? Yeah, there are many. No, we can't count it, no, because it there can be some decimal value also. Okay, so let's say that this is 2 volt and this is 4 volt. Okay, between 2 volt and 4 volt. Okay, if you consider this signal, there are infinite number of values. Okay, for example, 2.00001, 2.00002, like this. Okay, so you can't. If I ask you the perfect number, then you have only three. Okay, 2, 3, 4. But the decimals values are there also. Okay, between this 2 and 4, there are decimal value are also. If you consider 1 and 2, between 1 and 2, there are infinite number of decimals value. Okay, 1.001, 10,001, 10,000, 100,001. Likewise, we can't count. Okay, so between this 2 volt and 4 volt, you can't count the voltage values. Okay, okay. So between these two levels, there are infinite number of voltage levels. Infinite number of voltage levels. Okay, voltage level. Correct. Did you understand this? Okay. If you consider two numbers, between that two numbers, if you want to count with the decimal values, there are infinite number of values. Okay, we can't count them. Okay, so between this 2 and 4 voltage level, there are infinite number of voltage level. Okay, so if you consider this signal, this actually this is an audio signal. Okay, it is a voice signal. Someone is talking. Okay, so this is a voice signal actually. Voice signal, sometime it is called audio signal. Okay, audio signal. You can see some sample audio signals in the internet. Okay, you can see if you just type on the Google audio signal, you can get some audio signals. Okay, corresponding to different sound, you can get different audio signals. Okay, so if you consider the audio signals, okay, it is a continuous time signal, as well as there are infinite number of voltage level. Okay, so we call it digital signal, sorry, analog signal also. If the voltage levels are uncountable, or amplitude levels, okay, amplitude levels are uncountable, we can't say voltage, because there are no, there can be other type of signal also. Okay, okay, so we can't say voltage level. So generally we can say amplitude levels. If we have infinite number of amplitude levels, infinite number of amplitudes level, okay, amplitude level, it is an analog signal. It is an analog signal. Okay, if we have infinite number of times values, it is continuous time signal. Continuous time signal. Okay, so normally continuous time signals are analog. Okay, normally all continuous time signals are analog. Okay. Okay. Now let's say that. Okay. Now let's say that you want to somehow store this signal. You want to store this signal in a memory. Okay. In a digital memory, you have to store this signal. Okay. So this is analog signal. You have uncountable number of values. Okay. So this is analog signal. Okay. Uncountable number of values. Okay. So if you want to store this signal in a digital memory, okay. So there are different types of memory we have. The RAM, okay, ROM, okay, random access memory, okay, read-only memory like this, okay. There are many types of memories we have, digital memories, okay, and the implementations are also different, okay. So let's say that you want to store this signal in a digital RAM, okay, in a RAM, okay. So how you can store this, okay, because you know that if you consider any memory chip, okay, let's say you are going to store this signal in a memory chip, okay, memory circuit, memory chip, maybe in the Arduino board, okay. You want to store this signal in a memory chip, or let's say that it is in Arduino board, okay. So you have a limited memory, no? You have a limited memory, okay. You don't have infinite memory, okay. Normally we have memory banks like this, okay. Each memory banks has limited number of bits, okay, like this. I think you have already learned these things. Okay. So if you want to store this signal in a digital memory, can you directly do it? If you want to, another question I am asking from you, okay. So this is a digital memory, okay. Let's say that this is an Arduino board, okay. This is Arduino board, okay. So you are connecting this audio signal to Arduino board, okay. Arduino board, okay. So this is analog signal, no? This is analog signal. So you have to use the analog pin of Arduino board, okay. Let's say that you have used analog pin of Arduino board, okay. Now you want to store this signal. Now you want to store this signal in the Arduino RAM, okay. Arduino RAM. So can you directly store this in the Arduino board? You can connect it directly. Okay, you can connect it directly, no issue. Okay. But if you want to store it, can you do it directly only? Yeah. Yeah, I got one answer. Can anyone, can all understand my question? Okay. Now I am telling that now a person is talking to a microphone. Okay. Person is talking to a microphone. Okay. So microphone will generate an electrical signal. Okay. Electrical signal according to his voice. Like this. It is an arbitrary signal. We don't know. Okay. Now we know that we have learned that this signal is a continuous time signal, and also it is a analog signal. Analog signal. Because the amplitudes levels are infinite. We have infinite number of amplitudes level. Infinite number of amplitude level. Okay. So this is analog signal. Okay. Now you want to, okay, now the microphone, you have the microphone, okay. Now you want to store this signal in Arduino board, okay. So here you have Arduino board. Okay, Arduino board. Okay, now you know that this is analog signal. Okay, so you have connected this, the output of this microphone. Okay, so there are two cables. No, one is a line and one is a ground. Okay, so ground line you can connect to the ground pin of the Arduino, and the signal line you can connect it to the analog input. So this will be analog input. Okay, so you can connect it directly. Okay, you can connect it directly. Now you want to store this signal in the Arduino board. Okay, so can we directly store it? That is my question. ඔකට සමහරට ඔයා කරලත් ඇති ලැබ් වල. Arduino එකට අර පොඩි බසර් ඒවා වගේ කනෙක්ට් කරලා නේ. එන එක එන මොකක් හරි සවුන්ඩ් එක බීප් සවුන්ඩ් එකක් වගේ එකක් ස්ටෝර් කරගෙන. Yeah. Yeah, Mina. Your answer is correct actually. Okay. Okay. Yeah. Actually, we can't. Okay. We can't store the signal directly. We can't store the signal directly. What is the reason? Okay. What is the reason? Can anyone tell me what is the reason? Can you guess what is the reason? Yeah. Actually, your answer is also correct, okay, Minan? But that is not the answer I am expecting. Okay. Your one is also correct. Okay. The digital signals, digital value accept 1 and 0. Okay, I will once we come to the sampling section, I can explain why we convert this 1 to 1 and 0. Okay. I think I have already explained it. Okay. Okay. Actually, your answer is also correct, but now you can see that. Okay. Here we have a limited memory. Okay. In every circuit, we have a limited memory. Limited memory. Okay. But if you want to store the signal, okay, if you want to store the signal, you want to store the amplitude levels of this signal. Okay. You want to store the amplitude level of this signal. Okay. You are storing the signal means you are storing the amplitude levels. Actually, the voltage values of these signals. Okay. So this is an analog signal and there are infinite number of voltage values. No? Am I right? There are infinite number of voltage values. Okay. So here you have a limited memory. Okay. So But in this signal, you have infinite number of voltage levels. Okay. So you can't store the infinite number of voltage value in this limited memory. Okay. So that is the main reason why we can't store the signal directly. Okay. Actually, as you told, okay, we need the analog to digital converter, ADC, to resolve this signal into finite number of voltage values. Okay. Actually, ADC doing that things. Okay. It get only the samples. Okay. Some limited voltage levels of these signals and store. Okay. So these signals, this analog signal, we can't directly store here. Okay. Okay. So if you want to store these signals digitally in a digital memory, you have to do a processing here. Otherwise, you can't. Okay. Did you get it? The main reason is here we have infinite number of voltage levels. Right? Infinite number of voltage levels. Okay. But the memory is limited. Okay. Memory is limited. So you can't store all this voltage level in this limited memory. Okay. So that is why we can't directly store this analog signal. Okay. So you have to convert this to a digital signal actually. Okay. In a digital signal, okay, in a digital signal, you have finite number of voltage level. Okay. In digital signal, you have very importantly finite number of voltage level. But in analog signal, okay, analog signal, we have infinite number of voltage levels. Here, finite number of voltage level in digital signal, and in analog signal, infinite number of voltage. Okay. So if the voltage are finite, always it is easy to deal with it. Okay. If you have a finite voltage value, it is easy to deal with. Okay. So if you have infinite number of value, it is somewhat hard to deal with because you have infinite values. Okay, many values. Okay. So the processing is somewhat hard here. Here the processing is somewhat hard, but here the processing is somewhat easy because you have finite number of voltage level. Okay. So that is the main reason why we are using digital signals over analog signals. Okay. It is more easy to process. Okay. Okay. Now, so I think that idea you should have. Okay. That basic idea you should have. Okay. I hope you have that idea already. Okay. So any problem here? Now, basically, you should know what is a continuous time signal and what is discrete time signal. Okay. And again, you know what is analog signal and what is digital signal. You should know this too. You should understand this should very well. Okay. So in continuous time signal, you have infinite number of times value. Here you have infinite number of finite number of times value in discrete time signal. In analog signal, you have infinite number of voltage value. Here you have finite number of voltage value. Okay. Okay. Okay, now another thing. So, okay. Okay, now let's say that we have, let's take the audio signal again. Okay, this kind of random signal. Okay, you have this kind of random signal. Okay, this is a voltage and this is a time. Okay, now let's say you are sending this signal through a switch. Okay, now you are sending this signal through a switch. Okay, like this. Okay, now, okay, so it is like this. Okay, you have a signal generator. Okay, so that is the signal. Okay, signal generator will give you the signal. So in our example, signal generator is the microphone. This signal generator is the microphone. Okay, microphone එකෙන් තමයි මේ signal එක generate කරන්නේ, මේ audio signal එක generate කරන්නේ. Okay, so you have the signal generator that can be anything, microphone. Okay, it can be a camera. Okay, so it can be any sensor. We don't know anything. Okay, so it also can be a signal generator. Okay, in our labs we have signal generators, no? Okay, in our labs we have signal generators. Okay, so this can be a that kind of standard signal generator. හරි, තේරෙනවනේ මම කියන එකනේ. සිග්නල් එකක් ජෙනරේට් කරගන්න මොකක් හරි එකක් සිග්නල් ජෙනරේටර් එක. Okay, in our labs we have a standard, we have standard signal generators. Okay, so there are, using that one we can generate some basic signals, actually standard signal like sine wave, cosine wave, sawtooth wave, rectangular wave, like this. Okay, but other devices are also there that can be generate a signal. For example, microphone is a instrument. It also generates the electrical signal. If you consider temperature sensor, that is that can be interfaced with the multimeter, it is also generating a signal, electrical signal, according to the temperature. The microphone generates the signal according to the voice. Okay, and camera also can be, digital camera also will be generate a signal. Okay, according to the picture or according to the video. Okay, so anyway, any signal generator, if you have any signal generator like this. Okay, and if you connect the switch here. Okay, connect the switch here, and if you connect this again, let's say that you have connected to the oscilloscope like this oscilloscope or something. Okay, what happened when you on or when you on this switch? Okay, then the current is flowing through these circuits, no? Okay, and in the oscilloscope you can see a voltage value. Okay, can you understand what I'm saying? If you switch this for a while, if you switch this for a while, okay, for a tiny period, okay, here you can see a voltage value. Okay, maybe this way, some point voltage value you can get. Okay, now again you turn off the switch. Okay, now there is no any signal. Okay, okay, and again you switch off the signal, you switch off the switch on the switch. Okay, you on this switch, what happened? Again you can, the another voltage level can be appeared, so you can get another voltage like this. Okay, then you again open it, again close, then you can get another voltage level. Okay, likewise, once this switch is on, you can have some voltage value like this. Okay, well, voltage value like this. Okay. So the output signal is look like this. Okay. So this is our input signal. Okay. I will write the input signal here like this. Okay. So this kind of input signal we have. Okay. This is the input signal. Okay. This kind of input signal we have. And once you switch on this switch, you can have some voltage value. Okay. Then you off it. Again, you have a voltage value. Again, you have a voltage value. Like this, you will have some voltage value like this. Okay. Okay. So let's say that you are turn on you are turn on this switch and off this switch in a t time duration. Okay. So you have t here, 1t here. Okay. Here you have 2t. In this voltage you have 3t. And this voltage again you have some value. This voltage also you have some value. This voltage also you have some value. Like this you will have some values. Correct? Okay. So we will have this kind of signal, no? If you are sending this signal through a switch and switch is on off periodically, okay? So you will have this kind of signal. Okay. Are you okay with this? Do you have any problem? මේක තේරුණාද ඔය කට්ටියට? අපි මේ සිග්නල් එකක් යවලා මේ ස්විච් එක on off කරනවා. හරි? මෙයා on කරන වෙලාවට අපිට මොකක් හරි voltage එකක් පෙන්වනවා. off කරපුවාම නැහැ. ආපහු on කරනකොට voltage එකක් පෙන්වනවා. off කරපුවාම නැහැ. ආපහු මේවා කරනවා. අපි දැන් මෙයා අපි හිතන්න t duration එකකදී on off කරන්න කියලා. එහෙනම් t කාලයකදී මේක on කරනවා. ඔන්න අපිට voltage level එකක් එනවා. ආපහු off කරනවා. ආපහු t කාලයකට පස්සේ ආපහු මේක on කරනවා. අපිට voltage level එකක් එනවා. ආපහු off කරනවා. එහෙම අපිට ගන්නවා voltage levels. Okay. එතකොට අපිට එන්න මේ වගේ signal එකක්. Do you understand it? Vinojan, did you understand what I have told? Okay. We are sending a signal through a switch and this switch is on and off periodically. Okay. Let's say that after t times, okay, after capital T time. Okay. So once this on, you will have a voltage value. Okay. Once this is off, there is no any voltage values. Again, after t time, you have on it, then you can see a voltage value. Again, after again it is switch off instantly. Okay. Then again after t time, you are switching off, switch on the switch. Then again you can get the value. Likewise, you can get, finally you can get this kind of signals, no? Okay. Correct? If you have any problem, please ask me, okay? You should have this basic idea. Okay. Before going for a complex things, you should have this basic idea, okay? Okay. Okay, now actually this is now tell me, this signal is a continuous time signal, no? This time is a continuous time signal. What about this time? What about this signal? What is this signal? මේ signal එක මොකක්ද? What is this signal? Is it a continuous time signal? මේ signal එක continuous time signal එකක්ද? Okay. You have this kind of signal. Okay. Now you are sending it through a switch. Okay. Then this switch is periodically on and off. Okay. Then you will have some voltage values once the switch is on. Okay, like this. Okay. So this is the voltage value corresponding to this time. This is the voltage value corresponding to this time. This is the voltage value corresponding to this time. This is the voltage value. This is another voltage value. Likewise, we have this kind of voltage value, voltage signals. Okay. So this is you already know that this is a continuous time signal, and also it is an analog signal. Okay. Is this a continuous time signal? Make a continuous time signal. Please answer me. Yeah. What is it actually? What is this signal? Yeah. What about others? I got only one answer. What about others? I got only one answer actually. That answer is correct. Okay. What about others? Is this continuous time signal or another signal? This one. Yeah. Yeah, I got another answer. That is also correct. What about others? Okay, if you consider this signal, okay, if you consider this signal, okay, let's consider this signal. This is our original signal. Okay, this is our original signal. No? This is the signal generated by the microphone. Okay, this is the audio signal generated by the microphone. Okay, so if you get any two time point, okay, if you get any two time point, let's say that from here to here, okay, so you can see that you have infinite number of time values because all the time values are there. Okay, all the time values are there. Okay. Okay. Including the decimal value. Okay, so infinite number of times values are there between two specific time. So definitely this is a continuous time signal. Okay, but if you consider this signal, if you consider two time level, okay, if you consider any two time period, if you consider any time period between that two time period, you have countable values. No, here actually you have 1, 2, 3, 4, 5, 6, 6 time values. Okay, you have 6 times values. Okay. So it is a countable time value you have. Okay, so this is not a continuous time. This is a discrete time signal. Okay. Okay. All. What about others? Do you understand? Anyone have any problem? Okay. Okay. Actually, this switch is doing what is called sampling. Okay. This switch is doing what is called sampling. Okay. So in electronic circuit, you can use a transistor. Okay. You can use a transistor for this switch. Okay. So using the transistor, you can make a sampler. Okay. In the electronic circuit, in most electronic circuit, transistor is the switch of. This is switching part is doing by a transistor. Okay. Okay. Actually, so this is switch. This switch is doing the sampling. Okay. So this is called the sampling. Okay. This is what we call sampling. Okay. So you can see that we get only some sample, few sample here. So we have a signal and we get few samples here. The voltage samples. Okay. So that is why we called it sampling. Okay. So using a switch, you can do the sampling. For this switch, you can use a transistor or MOSFET. Most probably we are using MOSFET. Okay. MOSFET. Field effect transistor. Okay. Okay. Now, I think all of you can understand this. Okay. If you have any problem, please ask me. Okay. Yeah. Actually, Minan, in some books, okay, you can see that actually why uh, there is a reason I didn't mention this issue. Okay. In some books, it is said that all discrete time signals are digital. Okay. In some book, it is mentioned. Okay. If you see the Google, sometime you can see that discrete time signals are also called as digital signal. Okay. And definitely all continuous time signals are analog. Okay. All continuous time signals are analog. Because if you get the continuous time value, definitely between these two time values, definitely there is an infinite number of voltage levels. Okay. So this statement is correct, no doubt. Okay. But I am doubting about this concept actually. Okay. This discrete time or continuous time, normally we categorize based on the time axis. Okay. Continuous time signal and discrete time signal. Okay. Continuous time signals and discrete time signals. Okay. Normally categorized based on the time axis. We have already discussed. Okay. Actually, continuous time means if you consider any two time period, okay, between that two time period, the values should be infinite. You should have infinite values. Okay. In discrete time signal, if you consider any two time period, value should be finite. Okay. That is how we categorize continuous time signal and discrete time signals. Okay. So you can see that this is a discrete time signals. You can see that the time can be goes up to infinity. Okay. You can see that time can be goes up to infinity. Okay. This time can be goes up to infinity. Okay. We can't put a limit. Okay. But if you consider any two times values, between that two time value, you have a finite number of voltage values. Okay. But if the time is gone to infinity, there are again infinite number of time values. No? Can you understand what I'm saying? If this time is going to infinity, again we have infinite number of times values. But still we are talking in discrete time signal. No? They're not kidding. Okay. So if you consider the infinite times values, okay, again the voltage can be infinite values, no? Okay. Again, the voltage can be infinite values. If you consider the time up to infinity of a discrete time signal, again, the voltage also have an infinite number of values. Okay. So I think, okay, in most book, it is said that all discrete signals are digital, but I think all discrete signals are not digital, because discrete signals also can have infinite number of amplitude values if this time goes to infinity. Okay. But in some books, it is mentioned that all discrete time signals are digital. Okay. Okay. Did you get the answer for your question? I'm not sure it is clear or not. Okay. Yeah, it is clear, no? Okay. Don't take it too serious. Okay. So different books state different things actually. Okay. Sometime we can see that in up to some level, you can see that all discrete time signal, most of discrete time signals are digital actually. Okay. But sometime it can be changed also. Okay. That is my understanding. Okay. Okay. Maybe if you read this Shom outlines books, maybe you can find answer. Okay. I think that idea also enough. Okay. 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 Thank you for the question anyway. Okay. Now we have this signal. Okay. We have this kind of signal. And if we sample this signal, using a transistor or MOSFET, okay, you can get this kind of signals. No, you can get this kind of signal. We will talk about sampling thoroughly in future. Okay, but up to this level, please take this idea. Okay. So once you send this to a transistor, okay, you will get this kind of signal. Okay, this kind of signal actually. Okay. So this is a voltage and this is also voltage. Okay. Now you see that this is a continuous time signal and this is a discrete time signal. Okay. Now let's say that for any reason, okay, for any reason, you want to calculate, okay, you want to add all the voltage levels, okay, all the voltage level of this signal, okay. Let's say that from 0 to this up to this time, okay, you want to add, okay, you want to add all the voltage level of this signal. So how you add it? If you want to add this all voltage level, what we have to do? let's see that this is a power. Okay, this is a power. Okay, so if you want to find the total power dissipated up to here, okay, total energy up to here, you have to add all these power levels, no, power values. Okay, so that is how you want to find the total energy from 0 to t. Okay, you have to add this all the values, power values. Okay, so how you add this for a continuous time signal? What you have to do? Because there are infinite, so you already know that there are infinite number of levels, no, power levels. Okay, power levels from 0 to t. Okay, from 0 to t, from here to here. Okay, you have infinite number of voltage levels. Okay, so can you add it simply? Let's say that this voltage is 0, here it is around 2 volt, here it is around 4 volt, again here it is around 2 volt, here again it is 0. Now you have to add this point. So how can you do it? Anyone have idea what you have to do? What do you think? Can we add those? Can we add the sample together? Simply, can we add the sample together? Can or can't? What do you think? Actually, this add-in means, okay, this add-in means you are finding the area of this part, no? You are finding the area of this part, okay? Time with respect to voltage, okay? So what you have to do? You have to integrate it. You have to do the integration, okay? Let's see that, let's say that this signal is xt or something, okay? So you have to integrate this xt with respect to dt with respect to time from 0 to t. Okay, 0 to t. Okay, then you can add these values, okay, together. Correct? Okay. So you have to do the integration. If it is a continuous time or analog signal, you have to do a integration. Okay. If you want to find the sum, you have to do the integration. Okay. Is it clear? Is this clear? All of you? Because here we have infinite values. Okay, so you can't simply add them. Okay, then what you have to do is you have to integrate it in another ways. In another words, actually we have found the area of this part from 0 to t. Okay, is this clear? If you are getting if you are, let's say that if you got a sine wave like this, okay, now you find the area from here and here. Okay, this area and this area. Okay, that means you want to add the point from here to here, 0 to t. What you have to do? This is a sine function. Let's say that it is sine omega naught t or something. You have to add this signal from 0 to t with respect to dt. Then you can find the area of this signal. Okay. If you can't understand, please tell me. Okay, then I will try to explain it more. Okay. Okay, keep remember that you have to do the integration here because there are infinite number of values. Okay. What about this? Now you want to add the voltage level from here to here. Let's say that from 0 to t, again, around here, up to here. Okay. So what you have to do? So here you can have some voltage level. Now let's say that this is 0 volt, this is 2 volt, this is 3 volt, this is 4 volt, this is 2.5 volt, this is minus 1.3 volt, this is minus 3.8 volt. Like this, you have some voltage values. Okay. If you want to add this voltage value, what you can do? Can you add this voltage value simply or not? මේ voltage value අපිට කෙලින්ම එකතු කරන්න පුළුවන්ද බැයිද? What do you think? Yes. Yes, I got one answer. What about others? What about others? Yeah, that answer is correct. Okay. One student gave the answer. Okay, that is the correct answer. Okay, can we add them simply or not? What do you think? අපිට මෙතන ඉඳන් මෙතෙන්ට voltage values ටික එකතු කරන්න ඕනේ. අපිට voltage values ටිකක් තියෙනවා මේ වගේනේ. මේ මම නිකන් random බොරු values ටිකක් දැම්මේ. Okay. For the example, to get the idea. Okay. So now you want to add this voltage value from this time to this time, 0 to, let's say that t. Okay. Now you want to add this voltage value. Can we simply add them or not? Please tell me. I think you can easily understand it. Here in this case, maybe in the continuous time, maybe you can have some confusion. Okay. But here it is very simple and direct. Okay. You can give a direct answer. Can we add these voltage values directly or not? අපිට මේ voltage values ටික එකතු කරන්න කිව්වොත් එකතු කරන්න බැයිද? So if I ask to add, what you have to do, you have to add them. Okay, so here you have 0. This is the example. Okay, here you have 0, and again you have 2, again you have 3, again you have 4, then you have again 2.5, again 0, again minus 1.3, minus 3.8, minus 2 point something, like this. Okay, again we have 0. Like this, can't we add these values? We can add. Okay. So we get the algebraic sum actually. Algebraic sum, no, algebraic sum. Algebraic means we consider this plus and minus values. I don't know the word is correct or not. I can't pronounce it. Maybe my pronunciation is not correct. Okay. Algebraic, no? Okay. So we can get the algebraic sum. Okay. Is it a problem? No, we can get directly if you know how to add. Okay. Then you can add these values. Okay. So you no need to integrate here. Okay. So in the continuous time case, you have to do the integration. But in this case, you don't have to do the integration. You can simply get the algebraic sum. Okay. So normally we prefer it like this. Okay. Okay. And also you can see that we have this t, no? Here we have t. Okay. But here the t has a discrete values. Okay. So normally we are not using the times values here actually. Okay. We are not using the times values. We are just using the sample values. Okay. So this is the 0 sample, and this is the first sample. This is the second sample. This is the third sample. This is fourth sample. This is fifth sample. This is 8 sample. This is 9 sample, like this. Okay. So here we are not using t. Instead of t, we are using the sample number actually, because these are samples. Okay. These are samples. Okay. So normally we are using n, that indicate the number of samples. Okay. But there is a time value corresponding to this n. Okay. If you are taking this sample with respect to t time, okay, here it is 0 time, and here it is t, here it is 2t, like this. Okay. So for this n, there is a corresponding time value. You can understand this when we are doing the sampling, you will understand this more. Okay. But up to this level, you should have this idea. Okay. So normally, to represent the discrete value signal, we are normally not using the time value. We are just using the number of samples, this samples values. So this n can be 0 or n is the number actually, 1, 2, 3, like this. Okay. So the number can be minus infinity to plus infinity, including 0. If it is going to minus side, it will be -1, -2, -3, up to minus infinity. Okay. Okay. So here it is, x is a function of time. Here we normally refer the x is the function of n, number of samples. Okay. So this is how a discrete time signal is represented using n. Okay. 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 Can you understand these things, what I have told you? Okay. So I have told you actually, okay, if I again tell you the summary, if you have a continuous time signal, if you have a continuous time signal like this, okay, this is a continuous time signal. Okay. Okay. So normally the independent variable we consider time. Okay. So this signal x, the signal is the function of time. Okay. So normally it is represented using xt. Okay. And to add the values of this signal, you have to do the integration. Okay. From the corresponding time interval with respect to t. Okay, if it is a continuous time signal. Okay, so if you send this signal through a sampler, okay, and you sample it, okay, so you will have this kind of signal. Let's say that this signal has also have some minus value like this. Okay, so this signal, okay, this is the signal, okay, but in the sampler we have some sample like this. Okay, we have some samples like this. Okay, okay, so only samples we have. Okay, actually we don't have this values. Okay, sorry, I will write it again. Okay, so once you send it through a sampler, okay, you have some sample like this. Okay, like this. Okay, and actually this is also t. Okay, this is also corresponding to t, but normally we are not using the t variable, we are using n. This is called number of samples. Okay, this is the number of samples. Okay, actually there is a time corresponding to this n. Okay, I will explain it later. Up to now you understand this one. Okay, so this may be the zero sample. Okay, this may be the zero sample, this may be the first sample, this may be the second sample, this may be third, this may be fourth, this may be fifth, this may be sixth, likewise. Okay, 0, 1, 2, 3, 4, 5, 6, n. Okay, and also this one, -1, -2, -3, likewise. Okay, so it is a function of n. Okay, so normally it represents in xn. Okay, so if you get the discrete time signal, okay, it is a function of n. This n is nothing but it is a number of sample. Okay, actually n also related with the time. Okay, n is also related with the time. We will see how this relationship happen. Okay, later. Now understand this one. Okay, now if you want to add these points, okay, if you want to add this point, what you have to do? You have to get the sum. Okay, what you have to get the sum from any sample to other sample. Maybe one sample to another sample, n2. Okay, so this is the summary actually. Okay, okay, if it is a continuous time signal, it is a function of time, and time is discrete value, voltage also discrete. Sorry, time is continuous and voltage also continuous, so you have to do the integration here. And if you consider the discrete time signal, we are represented using sample, number of sample using n. Okay, so you have to get some sample values here. Okay, okay, so actually this is the most important thing. Okay, this is the thing you should keep remember. Okay, to continue this course, this is very important. Okay, do you have any confusion? Okay, if I represent it using function, if you have any continuous time signal, and if you send it through a sample, you will have the sample discrete value xn. Okay, so this is time, this is number of sample. Okay, if you want to find the sum of the voltage, you have to do the integration here, xt with respect to dt in some time level. Okay, if you want to find the sum of this signal, what you have to do, that you have to get the sum of this signal. Okay, xn from n is equal to 0, n is equal to maybe another one. Okay, like this. So you have to just add it, but here you have to do the integration. So anyone who couldn't understand this? මේක තේරුම් නැති කවුරු හරි ඉන්නවද? මේ ටික. මේක continuous time signal එකක්, මේක discrete time signal එකක්. හරි? continuous time signal එකක් නම් ඒකේ time values ගානක් infinite, amplitude value ගානක් infinite. හරි? එතකොට අපි සාමාන්‍යයෙන් ඒක time එකෙන්මයි පෙන්නන්නේ. continuous time එක time domain එකේමයි පෙන්නන්නේ. හරි? එතකොට ඒක xt කියලා. function of time. okay? ඔකට්ටියට මොනවා හරි sum ටිකක් හොයන්න ඕන නම් ඒ කියන්නේ voltage value ටික එකතුවක් හොයන්න ඕන නම් යම්කිසි period එකක ඔකට්ටියට කරන්න වෙනවා මේ signal එක integrate කරන්න වෙනවා t විෂයෙන් ඒ time period එකේ. හරි? discrete time signal එකක්. ඒ කියන්නේ මේ continuous time signal එකක් sample එකක් හරහා යවලා sampling කරගත්තට පස්සේ එන signal එක ඒක discrete time signal එකක්. හරි? ඒ signal එක අපි represent කරන්නේ n වලින්. t වලින් නෙමෙයි අතරම. ඒ වුණාට n සහ time එක අතර relationship එකක් තියෙනවා. හරි? ඒක මම පස්සේ කියන්නම්. හරි? දැනට ඔකට්ටිය මතක තියාගන්න මේක represent කරන්නේ n වලින් කියලා. හරි? එතකොට මේ n කියන්නේ number of sample number එක. sample number actually. So it can be from minus infinity to plus infinity. හරි? ඒක minus infinity වලින් ඉඳන් plus infinity වලට වෙන්න පුළුවන්. Okay? So it is represented as a function of n, xn. Okay? So any discrete time signal you are represent using xn. Okay? N means number of sample 1, 2, 3, 4. Okay? And if you want to find the if you want to add this point, ඔකට add කරන්න ඕන නම් මෙතන sample කීයේ ඉඳන් හරි කීයට sample දෙකේ ඉඳන් 5ට sample බිඳුවේ ඉඳන් 10ට පින 10 ඉඳන් 5ට මොකක් හරි sample ගණනක් add කරන්න ඕන නම් ඔකට කෙලින්ම algebraic sum එක ගන්න පුළුවන්. ඒ sample ටිකේ. හරි? integration එකක් කරන්න අවශ්‍ය නැහැ. Okay? අන්න ඒ idea එක තියෙනවා. Okay. So Vinojan, do you understand what I am telling? Siva Priya, Sasikumar. I hope you guys also understand. Okay. Unfortunately, I can't speak Tamil, so okay, then I can also explain it in Tamil. Okay. So if you have any problem, please ask me. Okay. You should understand this thing. Okay. Okay, now I will give you one exercise. Okay. Try to do this exercise. Okay. Okay. Now you have a signal like this. Okay. xt. Okay. This is the signal. Okay. So here it is. Here it is 1. And here it is also, let's say that 2. This is 2. Okay. This point is 2. Okay. So this is a line. Okay. And this is 0 and 0. Okay. And you have sampled this signal. You have sampled this signal. Okay. And you get, let's say that you get 3 samples. Okay. So here it is the first sample. Here it is the 0 sample. This is the first sample and this is the second sample. Okay. Okay. And let's say that this is 0 voltage. This is 1. This is 2. Okay. So this is representing n and it is xn. Okay. So now you want to find, okay, you want to add, you want to find the total amplitude from 0 to 1. Okay. You want to find the total, you have to add the amplitude level from 0 to 1. Okay. That means you have to find this area. Okay. So that is the definition of the integral. Okay. You have to find this area. Okay. And also you have to add these pointers. Okay. So try to find it. Here you need to find the sum value from 0 to 1. Okay, 0 to 1. Here also you want to find the sum value from 0 to 1. Okay. So try to do this. Okay. Okay. So this is a line graph, no? Okay. So this is a simple line graph. Okay. So the line, if you find the equation, okay, I will give you the equation. If you find the equation for this xt, okay, xt, you will have this kind of one. It should be half t, no? Sorry, 2t. xt is equal to 2t. This is the function of this time. Okay, so this is actually y equal mx plus c type graph. Okay, the m is 2 actually here. This axis divided by this axis, so 2 is divided by 1, that is 2. So m is equal to 2x. Okay, so c means the y-axis cutting point, that is 0. So this also will be 0. Okay, so xt is equal to 2t. Okay, find this one. Okay, and before that, tell me what is the value when t is equal to 0, 5, and here what is the value when n is equal to 1. Tell me. First tell me these two values. If you consider this circuits, this signal, what is the value at t is equal to 0, 5, and here what is the value as n is equal to 1. Okay, so give me these two values. Okay, and also try to find the sum. Okay, try to find the sum. Okay. So try to find this by yourself. Take around 10 minutes and try to find it. Okay. Take 10 minutes. Can you hear me? Can you hear me? Are you there?
Yes, sir, we can hear you.
Okay. Okay. So I take this one. Okay. I will write it here again. Okay. So I give you this signal. Okay. I will give you this signal. It's like this. Okay. So once the t is 1, the value is 2. The amplitude value is 2. Okay. And here it is 0, and here the amplitude value is also 0. Okay. So first of all, you have to find the function of this, the equation of this graph. Okay. First of all, you have to find the equation of this graph. Okay. So this is linear graph. This is a linear graph. Okay. Simple linear graph. Salarrekhiya prastha. It is in y mx than c form. Y equal mx plus c form. Okay. So here the x is t and y is xt. Okay. So you have to find the graph equation first. Okay. So to find the graph equation, okay, you are given 2 points actually, 0, 0 and 2, 1. Okay, using this 2 point, you can find the find this graph equation. Okay, I think I have told you that. Okay, if you are getting any point xy, okay, so using this two point, you can find the relationship between xy. Okay, so here it is xt t, sorry, t xt. Okay, here it is t xt. This is x and this is y, t xt. Okay, so you can find the relationship. Okay, so you can equal the you can equal this what is called gradient. Okay, this m is called the gradient. You can equal that gradient. Okay, the gradient is the tan value of that point. Okay, so here gradient is if you consider this gradient, it is 2 divided by 1, 2 divided by 1. And if you consider this gradient, it is xt minus 0 and t minus 0. Okay, xt minus 0 and t minus, sorry, t minus 0. Okay, so you can get that xt is equal to 2t. Okay, so this is the graph equation. Okay, so it's still, maybe if you are not familiar with this, that will be okay. Okay, I am not going to give you to find the graph equation in the exam. Okay, normally I will give this. Okay, for the exam I will give this. Okay, but you should have a simple idea how to find it. Okay, so this is the graph equation. This is our signal. Okay, this is a signal equation. Okay, now my first question is, what is the xt value? Okay, I'm asking the xt value. I think some student has misunderstood this. Xt values at t is equal to 0, 5. Okay, that means here, let's say that this is around 0, 5. Okay, let's say that this is the 0, 5 point. Okay, now I remove this one. Let's say that this is the 0.5 point. Okay, corresponding to this 0.5 time, I am asking the amplitude value, this value. What is this value actually? You can use this equation. Okay, when the t is equal to 0, 5, you have to apply this 0, 5 to here. Okay, so at that time, the xt is equal to 2 into 0, 5. That is 1. Okay, so here t is 0, 5. The answer is 1. Okay, the answer is 1. Is this okay? So this is the graph. I am asking the value of xt, value of the amplitude level at t is equal to 0.5. T 0.5 වෙනකොට amplitude value එක අහන්න. හරි. So xt is the amplitude value, and you have the relationship between the amplitude and the time. Okay. So instead of this time, you can apply 0.5. or කට්ටට කෙලිම මෙතෙන්ට ආදේශ කරයි 0.5. 2 into 0.5, it is 1. Okay. So you have the amplitude value 1. Okay. So that is the answer for the first question. Okay. Second question, you are asking to find the sum of the amplitude level from 0 to 1. You are asking to find the sum of the amplitude level from 0 to 1. So you know that this is a continuous time. Okay. So there are many values from here to here. 0 to here, there are many values. Okay. So you can't simply add them together. Then you have to do the integration from 0 to 1. Okay. Then you have to integrate this xt. Okay. This is to find the sum of amplitudes levels from 0 to 1. Okay, the time rate. Okay, from time 0 to 1. Okay, to find the sum of the amplitude level from time 0 to 1. From here to here, 0 to 1. You can't simply add them because there are infinite number of amplitudes levels. Okay, corresponding to this between these two time intervals. Okay, there are infinite number of amplitude levels between this 0 and 1. So you can't get the simple algebraic sum. So you have to do the integration. Okay, so you have to integrate this xt with respect to dt from 0 to 1. So what is the answer? Xt is 2t dt 0 to 1. So what is the answer? So if you integrate this, you will have 2t square divided by 2. The limits are 0 to 1. Okay. So 2 cancel, t square 1 0. So you can have 1 minus 0. The answer is 1 again. Okay. So if you add the amplitude levels, from 0 to 1, from here to here, okay, then you will have the answer 1. Okay. In other way, the area of this triangle is 1. Okay. So I think you know how to find the area of this triangle. Okay. It is this value into this value. So that is 1 into 2 divided by half. That is how to find the area of the triangle. Okay. If you have a triangle like this, if this is x and this is h, the area is xs divided by 2. Okay, so this 1 is 1 and h is 2. So 1 into 2 divided by half. So you will have one same answer. Okay, so this is, sorry, same answer here. This one, okay, same answer. Okay. So this is how to find the sum of amplitude levels. You have to do the integration. Okay, now I'm come to the discrete time signal. Okay, so now I have sent that signal through a sampler. Okay, then I get 3 samples only. Okay, this is my 0 sample, this is my first sample, this is my second sample. So number of samples n. So this is xn. Okay, so here the value is 0. The first sample value is 1. Second sample value is 2. Okay, this is the given signal. Okay. No? So n, this is the discrete time signal. So the first sample, the 0th sample value is 0. First sample value is 1. Second sample value is 2. Okay. Okay. So I have asked, what is the first sample value? When the n is equal to 1, what is the xn value? First sample value, what is the value? You can see this and tell me, what is the value? When the n is 1, what is the xn value? Very simple. Yes, very good. I got one answer. So it is very simple. Please tell me. I think all of you can answer it. Yes. Yes. I got answers. Okay, all are correct. Okay. So n is equal to 1, then that is n means the number of samples. Okay. This is the sample number. That is not the number of samples. Sorry, there is the sample number. Okay. The n is the sample number. So what is the first sample number? The sample number 1, the value is 1. No? This one. The amplitude value is 1. This is 1 voltage or something. Okay. So x n, when the n is equal to 1, xn, actually it is x1 because n is equal to 1. X1 is equal to 1. Correct? Okay. Now you know you need to find, okay, you need to find the sum of these samples. There are 3 samples. Xn have 3 samples. You have to find the sum. The sample is from 0 to 2. Sample from 0 to 2. You have to find the sum of the sample. So what is the answer? In the continuous time, you have to do the integration. But here you can do, you no need to do the integration. Instead of this integration, you can use this sum notation. This is the sum notation. This is the sum notation. This is the sum notation. Okay. Sum notation. So if you are given some value from n equal to some value to some value, that is means you are asking to add. Simply do the algebraic sum. Okay. Do the algebraic sum using the sign also. Plus and minus sign, you have to consider that one. Okay. Okay, very simple. This one also. Please give me the answer. If you add the sample number from 0 to 2, what is the answer for this? This is 0 sample, this is first sample, and this is second sample. 0 sample value is 0. The first sample value is 1. Second sample value is 2. Okay. In first question, you are asked the first sample value, x1. It is 1. Okay. Now you are asking the sum of these 3 samples, 0, 1, and 2. These are the sample value. This is the sample number. Yes. Yes, I got one answer and it is correct. Thank you. What about others? I got another answer that is also correct. What about others? I got only two answers. What is the answer? Okay, so here I am asking the sum xn from n is equal to 0 to 2. So you have to get the algebraic sum, okay? So you have to get n is from 0 to 2, okay? That means n is, you have n value is 0, n value is 1, and n value is 2. You have three samples, 0th sample, first sample, second sample. 0th sample, first sample, second sample. You have three sample value, okay? So if you get x1, x0, that is the first sample value, plus x1, that is the second sample value, x2, third sample. X0 is 0, plus x1 is 1, x1 is 1, x2 is 2, plus 2. So what is the answer? 0 plus 1 plus 2, that is 3. Okay. So you can get simply a addition. No need to do the integration or something. But here you have to do the integration. Okay. So that is the main, that is another main difference between the continuous time signal and discrete time signal. In case of continuous time signal, you are always dealing with the integration or derivatives. But for a discrete time signal, you no need to use derivatives or integration. Okay. Okay. So that's it. We will stop here. Okay. And in next week, we will study about the basic continuous, discrete time signals. Okay. If you can try to, uh, so signal classification, I think no need to do again. Okay. So we will learn some basic continuous time signal, basic discrete time signal. Okay. So you have learned this basic continuous time signals, okay? Unit step function, unit impulse function, complex exponential, sinusoidal signal. You have learned this, okay? So if you can try to remind this, okay? So we have discussed about this signal, okay? What is a unit impulse signal? What is a unit step signal? what is a sinusoidal signal, and what is a complex exponential signal. Okay. So in next week, we will discuss the properties of the discrete version of these signals. Okay. So if you have times, try to refresh your memory on the continuous versions. Okay. So we will discuss the basic discrete time unit step sequence. Okay. Okay, we will stop here. Okay. Thank you for your participation. Okay. If you have any problem, you can ask me. Okay. Then I will wait here another 5 minutes. So if you have any problem, please ask me. Otherwise, you can leave.